Team Yukti. So today we will be presenting you the phase 1 technical presentation. So our teammates will tell you what are our future plans on our technical works.
Hello guys, my name is Akash and I am the hardware division executive.
Hello, it's me Rohan. I'm the head of software division executive.
The hardware devices used in this project are LilyPad Arduino AFE4400 heartbeat sensor LM35 temperature sensor. The LilyPad Arduino is basically a micro-sensor controller board specifically designed for wearables and e-textiles. The physical appearance of this is a circle which has a diameter of 50 mm. The board in itself has a thickness of 8 mm and approximately 3 mm thickness for the electronics attached. The operating voltage of this device is from 2.7 volts to 5.5 volts. The input voltage is similarly 2.7 volts to 5.5 volts. The digital output pins are of 14 numbers, out of which 6 are PWM outputs. Analog input pins are 6 and the DC current per input output pin is 40 milliamperes. The given flash memory is 16 kilobytes, out of which 2 kilobytes used by bootloader, meaning it's boot up software. The SRAM is only 1 kilobyte and the EEPROM to be 512 bytes, where the clock speed of this device is set as 8 MHz, and this can be powered by using an external power supply or USB connection. The AFE4400 heartbeat sensor is an integrated analog front end for heart rate monitor and low-cost pulse oximeter, which has flexible pulse sequencing and timing control with 40 pins for interfacing. This consists of low noise receiver channel with an integrated ADC, LED transmit section and LED fault detection section. This has a very configurable timing controller helping the user to have complete control of timing characteristics and provide a low jitter clock to AFE4400. The communication in this device is done by SPI interface. The device is complete AFE solution packaged in a single compact VQFN40 package, which is 6 mm by 6 mm and is specified over operating temperature range of 0 degree centigrade to 70 degree centigrade. Used in industrial photometry applications, low-cost medical pulse oximeter, and optical HRM. The LM35 temperature sensor is a precision integrate circuit temperature device which has output proportional to centigrade measures. The advantage of the device is to have calibrated in Celsius or centigrade. The scale factor of this device is a linear plus 10 millivolts per centigrade. The accuracy in room temperature is assured to be plus or minus 0.5 degrees Celsius. The full rated temperature range is minus 55 degrees centigrade to 150 degrees centigrade, which is suitable for remote applications. This is of low cost due to wafer level trimming. The operating voltage is 4 to 30 volts and the current drain is less than 16 microamperes. The self-heating is low with less than 0.08 degrees Celsius. The typical non-linearity is plus or minus 1/4 degrees centigrade. The major applications are power supplies and battery management. Hence, these are the device descriptions that are to be used in this project.
In phase 1, we have interfaced the AFE4400 photometry, which is targeted for home health application with the Arduino LilyPad. With this, we are able to detect the pulse of the test subject with a good accuracy. As we can see in the flowchart, we have designed the algorithm in such a way that it not only displays the results in beats per minute, but also displays the ECG on the serial plotter. When it comes to the algorithm, we have designed it in such a way when the power supply is on, the photometry starts to detect the pulse of the test subject. And if the pulse is detected, then the data is collected and sent to the Arduino LilyPad for further processing. And if it fails to detect the pulse, after a delay it again starts to detect the pulse, and this is how we have designed the algorithm for pulse detection.
So this is what is our progress till phase 1. We from Team Yukti are really excited to move forward and complete our prototype. Thank you all for supporting us.